Okay, welcome to JC Connect. In the previous class, we were discussing about some of the stages in during the infection process. The first one, how exactly you are going to control the infectious disease. The first one, that is the elimination of the source of infection. Okay, so in the source itself, if you eliminate it, okay, from where it is generating. So then it is almost control of all of the diseases. Okay. So how exactly it can be eliminated? First one, adopting quarantine. Okay. Then destruction of animal reservoir. I already explained what is reservoir. Okay. Treatment of sewage. Okay. This is of course is very important. If you treat the sewage properly, see the equally normally it is going to generate from the sewage itself. Equally, is one bacteria which is responsible for the stomach diseases. So even this is the major source of your sewage. If the sewage is not treated and if it is directly enter into any of the river body, so then definitely the E. coli contamination will be more. Then use of chemicals by individuals to eliminate the pathogens. Okay, for example, the disinfection what we are talking about now. Okay, so this can be adopted as an eliminating method. Okay, so second, that is immunization of the individuals. So I already said that's a hard immunity. Okay, so means to increase the immunity of the systems. I already said that. So if almost all the peoples are vaccinated, or if the immune systems of 90 to 95% of the people is more, so then the disease attacking is also very less. Okay. So then we discussed the Chick's law. This Chick's law, it represents the rate of kill proportional to the time of contact and the concentration of the dis- disinfectant. That is, I already explained how exactly the time of contact and the concentration of the disinfectant is going to affect the disinfection process or killing of the any of the microorganisms. Then how exactly the disinfection is going to happen? So which are the stages are there? Okay. First, what it will do is that it will suppress the growth of the microorganisms first. Okay. For example, you have assume that in a tank you have around one, two, three, four, five bacteria are there. Okay. Assume that you have five bacteria are there. First, what it will do is that it will not allow to multiply. Okay, that is very important. We already know that how the bacterial growth curve will be there. It is almost exponential growth curve. We can call it as it is the exponential growth curve. It is exponential growth curve. For example, if you have two, it is a 4 means it is the 16 again 16 to 124 like that it is. Okay, so if it is 5x raised to n, okay, or e to the power x, you can call it as e to the power x. Hmm? First one, it is going to suppress the growth of the bacteria. Second one, it is going to kill the microorganisms. So whatever if five are there, definitely it is going to kill the five microbes. Okay, with the help of the chemical reactions and destabilizing the its metabolism. So one thing is that first one, for example, chlorine. I said it is a chlorine disinfection. The chlorine disinfection, then when it is going to react with this five bacteria, so the initial reaction is going to happen. Then it is going to destabilize once the reaction is going to start with the five bacteria. Okay, I'll explain what is that chemical reaction which is going to happen. Then the whatever the stable bacteria, five bacteria, assume that they are stable, it is going to destabilize. Okay, by changing the metabolic activity of that bacteria. It is going to change the metabolic activity of the bacteria. We'll see that how the mechanism is going to happen. Then what are the good requirements of an disinfectant? The good requirement of the disinfectants is they must destroy the kind and the number of pathogens within a particular period of time. Okay, so two kinds and the number of pathogens within a particular period of time. They must be neither toxic nor unpalatable or otherwise objectionable in required concentration. Okay, for example, what will happen is that normally you take bleaching powder. Even sometimes if you add a little bit extra, okay, rather than the recommended values, it should not cause any harm to an individuals. Okay, it should not be toxic or unpalatable. Unpalatable means, for example, water should not be toxic. Okay, if the water is going to be a toxic, then that we can call it as the unpalatable water. Palatable means pure water. Then they must be dispensable at a reasonable cost, safe and easy to store, transfer, handle, and apply. Okay. The one of the very important thing is that when it comes to some of disinfectants is concerned, okay, almost all the disinfectants are halogen. If you see the periodic table, if you see the periodic table, so there one separate line is there, that is halogen based elements. These halogen elements look like chlorine, bromine, iodine, so etc. So these are all halogen elements. Almost all the halogen elements are okay, are disinfectant. These are considered as the disinfectant. Sometimes what will happen is that the chlorine gas, whatever we are talking about, or this is um, very dangerous in excess concentration. Okay, it is very dangerous in excess concentration, and it is what will happen is that once you expose the chlorine, always the tendency is to escape. Okay, the tendency is to escape from that original position. Okay, so that is why always this chlorine gas, it will be stored in just like your LPG cylinders. Okay, in LPG cylinders, just like in LPG cylinders, even the chlorine is stored. Even if you inhale the chlorine gas, okay, definitely you will become unconscious immediately. Okay, that much it is dangerous. So that is why this chlorine gas sometimes they will avoid in drinking water treatment, rather than they will use the bleaching powder. See, in bleaching powder, how exactly they will do it? Even bleaching powder formula is nothing but CaOCl2. Here also chlorine will be there, but the chlorine gas, it is a gas, plus your CaO it is the unhydrated lime. Okay, so there they are going to mix under pressure. Under pressure, these two are mixed and they are tightly closed. Okay, they are tightly closed in a plastic packets. Okay, and remember that the plastic packet should be leak proof. Means even a small hole should not be there. If that is there, there is a tendency of the escaping of the gas from the bottle. Once it is escaped, means almost all the chlorine is going to out. Okay, only it will remains the calcium oxide. Only it will remains the calcium oxide. Okay, so like this kind of disinfectants, if you use it, so as far as the good quality of the disinfectant is concerned, okay, it should be reasonable cost, it should be safe, it should be easy to store, easy to transfer, handle, and apply. In all the cases, it has to be satisfied. Okay. They should not require high skill and costly requirement for their application. Okay. Remember that these should not requires high skill and costly requirements. See, of course, if you need a skilled person for handling and requirement, the operating cost will be very high. So when you say the operating cost, the operating cost, it depends on the daily needs or daily maintenance of the any of the treatment plant. Okay. Suppose if the skilled person is required, if the skilled person is required, you have to pay more. Okay. So then automatically, totally the operating cost of any of the treatment plant is going to increase. So that should not be, that should be avoided. So as far as possible, okay, even a common man can handle the operational problems or the operating systems of the treatment units. Okay. So then they should be such a nature that their strength or the concentration of treated water could be determined. Okay. See, concentration yesterday I was explaining about the strength and the concentration. Strength and concentration in the sense how much concentration in terms concentration is measured with the help of milligram per liter. So how much milligram per of chlorine or the bleaching powder you are adding in terms of 1 liters or in a quantity or the known volume of the water. Okay. If that is if that is the case, it is very easy to calculate the amount of bleaching powder it is required to kill the pathogens. Okay. That kind of disinfectant you have to select. Okay. Suppose if you are unable to calculate the strength or the dosage of the any of the disinfectant, suppose if it is very tough to calculate it, then you have to avoid that. Okay. Next, their dose should be such that it leaves some residual concentration for the protection against the contamination in water during its conveyance and retention. See, the sixth point is very important. As far as possible, okay, if you see the overall network diagram of the our water supply system, if you consider the network diagram of water supply distribution network. So how exactly it will be starting from intake structure. It will start from intake structure, means in intake structure where the water will be pumped from the lowest locations. You can take the river, from the river we'll pump it, then it will be water treatment plant, then it is distribution network. So this is in water treatment plant. We were already started with a discussion that starting from the aeration. Now we have come to the disinfection process. So now let's see. You have in river water. Assume that you have around 1,000 pathogens are there. 1,000 pathogens are there. Okay. So then after water treatment plant, assume that you have killed all the pathogens. You killed all pathogens. Okay, you killed all the pathogens. Now when it comes to an distribution system, okay, so when it enters to an distribution network or water supply distribution network, See, here you won't get any pathogens, but see, during conveyance or during the distribution network, sometimes what will happen is that uh, due to the leakage in the pipes, okay, or sometimes during the maintenance, or sometimes if after 5 or 6 years, even wherever the collars will be there, collars in the pipes. Normally, collar it is nothing but, see, one more pipe will be there here, just like collar, which is very important component of any of the pipes. Sometimes if any leakage is going to happen in the collars or in the collar joints, okay, there sometimes if it is any sewage or if any the pathogens which are present in the soil, definitely it is going to enter into the pipe. So how exactly it is going to enter? See, most of the time if you see any of the road networks, okay, so normally on the center of the road, the your drainages will be there, okay, one side, okay, assume that this is your road, this is your road. Okay, at the center you can see uh, the wastewater or the municipal wastewater conveyance line will be there. Okay, and on the one side you have the water supply distribution network will be there. Suppose if the leakage is happened in the wastewater line, here you can say it is a wastewater line. Okay, if any leakage happened in wastewater line, so definitely then it will go and it will reaches to an water supply line. If here also if any collar in anywhere, if any joints will be there, okay, definitely it will enter to this water supply line. See, once the sewage enters to a water supply line, okay, in unavoidable circumstances, we can say it is not always, in unavoidable circumstances. So if this much happened, then what will happen is that your pathogens are going to increase here. So here you disinfected, you killed all 1,000 pathogens, but during the distribution network, uh, due to some unavoidable circumstances, or due to say during some repair works or whatever it is there, if anything is damaged, suddenly it will enter to the wastewater enter to a water supply line. So then I already said that your municipal wastewater, it consists of lot of pathogens, okay, lot of pathogens. Then the pathogens will enter to this water supply line. So then how we are going to disinfect that? Okay, how we are going to disinfect that? So what we will do here is that we'll add some extra disinfectant. Okay, for example, assume that you have 1,000 pathogens are there. Starting, I have given examples. For killing of the 1,000 pathogens, I requires 100 milligram per liter of bleaching powder. Assume that I require 100 milligram per liter of bleaching powder. So if you add 100 milligram per liter of bleaching powder, so you are going to kill the 1,000 pathogens. But I need some extra chlorine, so that to stop the further contamination which is going to happen in the pipelines or conveyance systems. So then what I'll do is that 100 plus some extra 10 milligram per liter, I'll add. So this I can call it as a residual disinfectant. Residual disinfectant. Residual means after disinfection process. So after killing of the 100 pathogens, extra 10 milligram per liter has to be left in the pipelines, so that further contamination can be stopped. Suppose if immediately if pathogens are going to enter into the conveyance systems, here in conveyance systems in the pipelines, this 10 milligram per liter of disinfectant will be used to kill the um, kill the pathogens which are present in the conveyance system. Okay, so normally we can call it as a residual disinfectant. Residual means it is remaining, okay, remaining after disinfection process. Okay, So this is what the meaning of the sixth point. So their dose should be such a that it leaves some residual concentration for protection against the contamination in the water during its convection and retention. Okay, even if the water is not only for this, even in the pipeline system, if the water remains for longer days, okay, definitely inside the pipeline only the funguses or some of the protozoa are going to develop. Okay, so to kill that or to control that inside the pipeline, okay, so we are going to provide some extra dose of chlorine, extra dose of chlorine or disinfectant to kill the further or to prevent the further contamination. Then which are the properties of disinfectant? So then it should be harmless, unobjectionable taste. So some of it should not contain any taste, okay, and it should not alter the taste of the water. It should not alter the taste of the food if you are using the water for the cooking purpose. Then it should be economical, should be easily measurable. It should maintain a residual. Residual means I already explained what is that residual disinfectant. It should not react with all the normal constituents. This is also very important. Okay. See, what will happen is that mm, in water we require some micronutrients for our body. Okay, around 14 micronutrients are there. So we require calcium, we require magnesium, we require with some proportions. Okay, so whatever the disinfectant is there, it should not react with the all normal constituents and form some other compounds. Okay, it should be like what, inert. Hmm? To inner to what? Inner to the sum of the constituents that are present in water. Okay. Should be easy to handle and operate. Remember that it should be easy to handle and operate. Then some of the methods of disinfection. So two main methods are there. First one, that is physical method, and the second one, that is the chemical methods. Okay, which are the physical methods? Physical method is, it is a disinfection by heat. If you start boiling, okay, if you start boiling any of the water, so that is also one process of disinfection. Okay, disinfection, if you boil the water, definitely you are going to kill the pathogens. Okay, then normally it is costly due to the pasteurization process, so it consumes a lot of energy. Okay, if you want to kill the pathogens. Okay, then disinfection by light. Okay, even if you apply the UV radiations to any of the pathogens, okay, bacteria, so it is going to, UV light is going to kill the pathogens. Even the gamma radiations, okay, UV radiations as well as the gamma radiations are used to kill the pathogens. Okay, it is also an excellent disinfectant. Even some of the sunlight based UV radiations, sunlight based UV radiations can be used for the disinfection process. Okay, it is an excellent disinfectant. It does not leave any known chemical residual. This is also very important because even your UV rays, what we are talking about, it will not leave any of the residuals. But as for our requirement, um, the residual disinfectant is required in up to some places. Like if you're in a drinking purpose, if you're supplying it, residual chlorine is required. Suppose in like swimming pools, if you are using water, okay, so there you can use UV. So there will not expect the residual chlorine. Okay, so wherever the applicability will be there, There we'll apply this all kind of disinfection process. So efficiency of the disinfectant is depends on the first one, that is the depth of penetration, time of contact, turbidity of suspended solids that may reduce the depth of penetration. See, assume that in a swimming pool itself. Okay, assume that in a swimming pool itself. So you have different depths will be there. You have in one swimming pool, there also in single swimming pool, in whole. Okay, up to 1.5 meter depth, 1 meter depth. Okay, 0.5 meter depth. Okay, based on the kind of persons or based on the applicability that will be used. Okay, see, if you add a chlorine to the swimming pools, so up to what depth it is going to penetrate. Okay, that is also very important. If it is penetrating for the almost all the depth wherever it is covered, then it is a good disinfectant. Suppose if it is treating only on the surface, then it is not suitable. Okay, if for example assume there is a swimming pool of depth of 1.5 meter. Suppose if you add the disinfectant here, it should penetrate up to here. It should penetrate up to the last bottom portion of this swimming pool. So that is also one the main thing where the efficiency of the disinfection process depends. Okay, so it has own restrictions. Okay, it has its own restrictions. Okay, up to extent of 1.6 on 1.8 meter it can reach. Okay, then how much time you will give the contact time? Normally, for example, you have the pathogens are here, you have seen that you have 100 or thousands are there. Okay, then if you add chlorine to this and if you keep it for longer time, I already explained the Chick's law. Okay, see, if you keep it for 30 minutes, how it's whether all 1000 or 10,000 pathogens are going to kill, whether can I keep the longer time so that all the pathogens are going to be killed. So that all depends on the time of contact also. Okay, so if you keep it for long time, you can say the killing of the pathogens will be more, and the turbidity and suspended solid that may reduce the effect of depth of concentration. So if the water is turbid, okay, the efficiency of the disinfectant, definitely it is going to affect. Okay, efficiency, because it won't penetrate for the longer depth. That is the big problem. If it is clear, it is going to enter into the higher depths and it is going to kill the pathogens which are there in the bottom of the tank. Then chemical disinfectants. See, some of the chemical disinfectants involves the oxidizing chemicals. So you have oxidizing agents and reduction agents, or the oxidation reactions and reduction reactions. See, oxidation reactions, it involves the loss of electron. Okay, the reduction reactions, it involves the gain of electron, that we already know. Okay, some of the oxidizing chemicals, these comprises of the halogens, that includes the chlorine, bromine, iodine. I already explained. Okay, if you see the periodic table, in the periodic table you will see that some of the halogen compounds, they are all the disinfectant compounds. Then ozone, normally this we can call it as O3. Then other oxidants like hydrogen peroxide and potassium permanganate. So based on the applications, wherever it is there, if you go to the medical applications, chlorine normally it won't be used. They will use the iodine, they will use the UV, but only some in some drinking water treatment process, normally we will use the chlorine as well as the UV rays. Okay, in some applications we'll use hydrogen peroxide also. So wherever, for example, industrial effluents, if you are treating it, if you are doing the disinfection process, so then the hydrogen peroxide will be used. Then some of the metal ions. Uh, Definitely going to affect the alter the immune system of the bacteria. So once you alter it, so it is going, the pathogens are going to be weak. It is going to kill. Some of the copper ions are also strongly recommended for the killing of the pathogens. Some of the alkaline, so acids and bases are also used about. So CaO or CaOH twice. These are recommended for the disinfection process. Alcohols, phenols, and phenolic compounds. Even most of the sanitizers will use sanitizers now. Okay, they all consist of proportion of alcohols. Okay, some of the surface active chemicals. Okay, um, the surfactants. Okay, for example, the washing powder which you use it. Okay, it is also highly recommended for killing of the pathogens from the only surfaces, not inside. Means it cannot be used in the water treatment process, but you can use it for your washing of the clothes and all those things. So there all comes under the surface active chemicals. So almost all the surfactants are used as a surface active chemicals, and they're definitely going to kill the pathogens which are retained or on the surface of any of the body or surface of the clothes. In summary, it can be said that for routine disinfection of a municipal waste and industrial wastewater, only one chemical, the chlorine, is both efficient and reasonably cheap. Okay, second is ozone, but relatively expensive, but persistent enough for monitoring purpose. Okay. First one is chlorine, then the ozone will be used for the disinfection process. The first priority will be chlorine. Why? Because it can be some of the common properties of the disinfectant what we have discussed. So it is going to satisfy 90% of the qualities of the disinfectant process. Second one, ozone. Why they have kept it in ozone is that the ozone creation itself is a problem. You require the ozone generator. So ozone, it is nothing but O3. It is O3. How the O3 can be created? So O2 plus nascent oxygen. Okay, so it is going to create. So you require a ozone generator for this. Okay, some of the special equipment is required. Even handling, be very careful. Okay. Okay, then some of the common methods, exposure to sun, boiling, halogens, ozone. So all this we'll discuss in detail in the next class. Okay, so one by one we'll take up and we'll discuss. Okay, if you have any doubt, you can ask or we'll wind up.